Cisco networking. That is the first module, CCNA 1, Introduction to Networks. And the first topic, or day 1, I'm going to explore the network. Let's embark on the module. This is chapter 1. This is chapter 1. As you can see, pay attention as we move together. These are the sections and the objective we're gonna achieve throughout this chapter. We are going to talk about how multiple networks are used in our daily life, how networks affect our interaction, our learning, or our work and play. And I'm also going to explain how host devices can be used as clients, servers, or both. Also touch something about types of networks, that is local area networks, wide area networks, and the internet. And also the network as a platform. So in our changing environment, networking has brought a lot of changes which have affected how we do business, starting from small scale business or large scale enterprises. Also, the trending technologies that have changed how networking works, like BYOD, bring your own device. This is a concept whereby users in an organization come in to work with their machines or with their own devices. That is, in one way, it is an advantage, and on another part is a disadvantage. From the security perspective, that's a disadvantage. From production standpoint, that stands to be an advantage. Networking has also promoted online collaboration, whereby people now can coordinate and share information irrespective of the distance. It has also enabled video and video conferencing. Through networks, you can just conduct a meeting as if you are in the same room. Also, networking has enhanced cloud computing. This is the provision of IT resources over the internet. And you can see the internet is a collection of interconnected networks. The networking also, throughout the ages, technologies have changed, not limited only to home, not businesses or enterprises. We've got technologies in networking that have changed the operations. Also, now, apart from enjoying the benefits of the network, the revolution or the technology advancement in the area of networking, there are some of basic security threats and security threats. You see, now the cyber attackers or threat actors have gained a platform whereby they can attack and intrude in systems despite of their location. Also, the networks functions on the aspect of switching and routing. I'm going to explain more about that in the later sections. So this is globally connected. One, network or internet is globally connected. Globally connected means majority of the many networks have been integrated together to cover a greater part of the globe. Irrespective of where you are, you can share, connect, and collaborate with one another, either for business purposes, education purposes, or any other. Networking today. Pause a bit, think about how networking today has evolved, or how networks have stand a chance to better the life of human beings. As you can see here, children are in the class or reading. All of them, they are sharing the information here on one platform through the help of the network. So in one way, apart from just sharing information here, it has increased the interaction rate or the interaction level of these people. Because if at all the network could have not been in place, interaction today could be the problem. When we compare the technology in 20 years ago and 20 years and now, we see there is a great difference. Right now, we used to have what we call mainframe computers, where a computer is more large than the modern house. But right now, a computer is just a small device, even can fit in the palm. As you can see in the second picture here, these are globally connected world, whereby you see these links. These are the networks that are covering the entire globe, irrespective you are in Asia or in Africa or in USA. Communication still just happens when you connect to the internet. There is this question: what wouldn't we have without the network? What is it that we could have lacked if the network is there? Think about it. Write your answer in the comment section. I'll ponder over it or I'll check. Networking today has removed boundaries. This one I had explained it before. Advancement in networking technologies are helping to create a world without boundaries. A world without boundaries. Right now, you can partner with people from any continent, then just behave as if you are in the same room, come to a decision, discuss something, and achieve what you're after. The immediate nature of communications over the internet encourages global communities. It is true. Right now, we as developers or network engineers, we've partnered through communities. There are platforms that we interact with our fellow colleagues in that niche from different parts of the world. Without leaving this behind, Cisco refers to the impact of the internet and networks on people as human network. It is true, human network, because it helps human a lot. Second benefit of networking, it has helped to revolutionize learning. Right now, you can access learning resources on a single click, and these resources are far away, thousands of miles from you. For example, a teacher in Moscow can just upload notes and share a link to thousands of students across Africa, and such will be possible only through the network. Now assume if at all it couldn't exist. Chaos. The second benefit, network has supported our work. Network supports the way we work. How does it support the way we work? For example, software engineers or tech crews have been helped by the network to ease their working style or to increase productivity in their lane of working. In that now, they do work with multiple tools, and these tools cannot be accessed without the network. Apart from that, there are some IDs that have been created and can be accessed irrespective of the location and still learn a certain language in that arena. If we come back here, The globalization of the internet has empowered individuals to create information that can be accessed globally. This is true. Forms of communication. In the ancient times, people used to walk on foot, blowing horns, etc. as forms of communication. But right now, just in a single click, you communicate or you pass a message to a person who is far away from you. We've got social media handles, the likes of Facebook, TikTok, YouTube even, and others. You see that one are just corridors for interaction too. We've got collaboration tools. These are tools like Zoom, Teams, TeamViewer, just to name a few. We've got blogs, giving people an online branding, like explaining who people are online through what they do. Networks have supported the way we work, also through data networks. You can see have evolved into helping support online learning opportunities, decrease cost. Generally here, I'm just talking here the importance of network. One, it has revolutionized the way of learning, supported businesses, increased human communication, or generally improved the way communication is done. And here, supporting corporates now through the employee training. And all that, networking has cut costs in many of enterprises. Because, for example, one printer alone can be used in the entire organization if and only if it is configured to work on the network, whereby you can just print your job through a shared IP address and it is done. Don't you see that that is a benefit to the management or to the finance section of that organization? They have saved a lot of people by giving each one of them a printer. Networks have also revolutionized the way we play. You can see in football, whereby we've got real-time systems that manage and analyze football. So this is a lab researching network collaboration tools. Use part 1, these are objective. Use collaboration tools. Part 2, share documents with Google Drive. Explore conferencing and web meetings. Create wiki pages. I will do this after finishing this particular class. I will share this particular notes with you. That is already achieving objective part 1 and part 2. Now, I'm going to discuss networks in terms of sizes. Networks exist in terms of sizes. The first size, the first type of the network, we've got small home networks. These are just connected to a few computers to each other and the internet. It means these are the selected few computers in a home that are connected to the internet. For example, in this cupboard here, you can see this is just one TV screen here. We can say that this is one computer. If it is connected to an internet, that one forms a small home network. Second picture, we've got small office / home office. Sometimes it is abbreviated as SOHO, S-O-H-O. So that kind of a network, it exists in a small, medium organization, whereby It enables computer within a home or remote office to connect to a corporate network. You can see it's just it's not so that big network. Then the third, we've got medium to large networks. These are now, you may find them in campus areas, universities, big institutions, many locations with hundreds or thousands of interconnected computers. So this, for example, like a bank having a headquarters maybe in South Africa and some branches maybe in Egypt, Sudan, maybe Kenya. So that is a medium to large network, an example of such. And you see the interconnection of all this have formed what we call the internet, or has formed what we call the worldwide networks. This connects to hundreds or millions of computers. This is an example of what I'm meaning. Let me just come back a few. This is one of the, if you can see my arrow, this picture here, it's one of the worldwide networks, or the internet. You see, these are millions of nodes connected together. So the next section, I'm going to talk about clients and servers. A client is a computer. It can be a computer or a node in a network that is accessing information or resources generally from a server. And a server is a special computer powered to provide a dedicated service, which can be and maybe email, maybe DNS or web, or file. Those are the servers. Servers host services. This kind of computer always needs to have a static IP addresses, because they host shared services. Assume if at all their IP address would be changing time to time. You want to access a resource, you cannot find the computer on the network because the IP you used yesterday to access the file or the web has changed. So chaotic, and it interferes production or operations in corporates. So these are two words that you should understand if you are a network engineer. Clients connect to the servers to receive or to get information. Servers provide responses or resources to clients. As you can see here, this is a switch. It is connected to a computer here, web client. This is an email client. It can be a Gmail, Outlook, or Hotmail, etc. This is a web client. It can be a browser, that is maybe Firefox, Chrome, Safari, Tor. Those are kind of browsers. A file client, it can be FileZilla. You see? Now this section is servers. This computer here is a file server. It is hosting file. In my later videos, I'll explain ADS, Active Directory Domain Services. That is an improvised section for this. This computer stores the organization servers. For example, this is a user here. This is a user wants a file about maybe the letterhead of an organization. He is connected to the switch. Then he sends that response to this server through the switch. Same applies to web client to web server, email client to email server. I'll do a lab on this and see how the information flow. So clients are computers that send requests to the servers to retrieve information such as web page from web server or an email from an email server or a file from a file server. Then servers are computers that provide information. So servers provide, then clients send requests to servers. So you should understand that. And the environment in which clients access servers, then servers provide information or resources to clients, it is called client-server architecture. So this is one of the how resources are provided. It can be on client-server architecture, and majority of the organization rely on this particular form of platform. So we've got another form of network connection, peer-to-peer. In peer-to-peer, all computers can serve the same role, can behave as a server when sharing the resource, or can behave as a client when sending the request to the other. So clients and server software usually run on separate computers, you see. But in this section, server software runs on a dedicated server here. Then client software runs on the client. For example, you install a Gmail on your computer, then you access a Google server. Google server is having the web users, the Gmail users. So you authenticate yourself against the Google server. That's when it works. So same applies here. Servers have dedicated software, then clients have dedicated client software. But when it comes to peer-to-peer network, clients and server software usually run on separate computers. However, in small businesses or homes, it is typical for clients to also function as a server. You can see here. You can see, though my cursor is so white here, the client can also function as a server, and a server can also function as a client. So you can see here, these are print sharing, file sharing, then these are printer. You see? That is it. There is a disadvantage here. There is no centralized administration. Not as secure, not scalable, slower performance. This means there is no dedicated administration for this kind of layout. Also, it is not secure because if at all this link is terminated or has a hitch, then the entire network is down. Not scalable. It is difficult to expand this kind of architecture here. Also, there is lower performance because this link supports all the nodes that are there. Assume we've got maybe 10 nodes here, you see, and it is running fast Ethernet. That is 100 Mbps. It cannot support all those 10 nodes. So its advantages is that peer-to-peer networking is easy to set up, less complex, and lower cost. Types of networks, we've got LAN, we've got WAN, and the internet. LAN is local area network. This is a private or internal network in homes or in the organizations. Wide area networks, these are networks that composed of multiple LANs, and it also connects a wider area. Let's go deeper here. Overview of network components. A network can be as simple as a single cable connecting two computers, or as complex as collection of networks that span the globe. So, networks that span like a metropolitan area, multiple of them, that is wide area networks. and the one that is within the organization, that is the LAN, local area network. So there is network infrastructure contains three broad categories of network components. We've got devices, media, and services. Devices, these are things like LAN. These are things like mobile phones, computers, those are devices, smartphones. Media, these are the links channeling information between the servers and the clients. And you find mostly that services are hosted in servers, and servers always located in the data center. So these are the things you should know, that there is no salient network infrastructure that misses these three broad categories: the devices, the media, and the services. Devices access services through the media. You can see from this image here, this is a LAN. It's having a server here. This is a switch. These are an IP phone. Then these are computer. So these are the devices. Then we've got this particular circle. It has 4 routers interlinked to each other. So in this section is where routing happens. So this is the decision engine that decides how the packets flow, or how patterns are dedicated or determined to route the traffic. This is a second LAN. The next section here is network components. So network components, they are categorized depending on the location. For example, here, the end devices. An end device is where a message originates from or where it is received. Mostly, this is at the access layer. That's where users resides. So data originates with an end device, flows through the network, and arrives at an end device. This aspect of flows through the network, this is the aspect of the media. It passes through the media. You can see this is the LAN, this is the LAN. Data is moving from this particular router to this particular LAN. So messages can take alternate routes, and those alternate routes are determined by these devices that we call routers. I'll discuss more about that and what they do. Next, we've got intermediary network devices. An intermediary device interconnects end devices in a network. For example, in this topology here, this section of internetwork, this is an intermediary section. It is composing of network routers. This section can be with the firewalls or switches. And when I say switches, in Cisco, we've got layer 2 switches, mostly used in LAN, and layer 3 switches that serves as LAN switches and also as routers, depending on the objective. So these are devices that are positioned in the center of the network. It includes switches, wireless access point, routers, and firewalls. This is the common question that you should put into consideration whilst revising or studying for CCNA, because the chances of missing is very rare. So the management of data as it flows through the network is also the role of an intermediary devices. So sometimes you find that in your network you must have one of these devices, and mostly the router. The ISP provides the service or the link to your internal router, so that your internal router is the engine that routes or determines the path your packets takes to reach the internet, or for you to be connected to the internet. So there are some of the roles that are performed by intermediary devices. One, intermediary device regenerate and retransmit data signal. So this is mostly applies to wireless router or the access point. If your Wi-Fi is so low, the signal is not reaching a certain point, you can interconnect another access point to boost that particular area. Number two, maintain information about what pathways exist through the network. That's the role of a router. The router is the one that decides which area your packet flows and how the packet behaves when it is within the network. Notify other devices of errors and communication failures. So that mostly is achieved by a router or a firewall, depending on the configuration. Network media. These are sections that a network engineer cannot afford to miss or misunderstood it, because media is one of the pathways that network is anchored on. As you can see, we've got types of network media, and they are used depending on various factors. Here is copper. This section here, this is copper. You can see how copper looks like. This is like a normal a normal Ethernet cable. That's copper. Two, we've got fiber optic. You can see these are their connectors. This is the cable. Then these are their connectors. This is the copper cable. Then these are the connectors. The connectors are called RJ45, and they are in families. We've got RJ11 for phones, then RJ45 for normal UTP. So go and read about such. Fiber optic also, its connectors come in different families depending on the connection or where to be connected. And we've got the wireless one that relies on the microwaves. So communication across the network is carried through the medium, which allows a message to travel from source to destination or from one place to the other. Networks typically use three types of cables. That's metallic wires within cables such as copper, glass ones for fiber, then wireless transmission. I'll talk about factors to consider when choosing a network media. For example, as a network engineer, you can be given a scenario that they want that network, maybe they want a connection between 2 points, and they give you that maybe latency should not be the case, meaning transmission should be so faster. And maybe there must be no EMI, electromagnetic interference. So when you hear about those two features, just know that fiber is the only cable that will achieve that, because fiber is meant for higher transfer speeds or higher transmission rates, unlike the copper cable. Also, fiber is not affected by electromagnetic interference, unlike copper. Fiber can also be connected to for a longer distance compared to copper, which is limited to 100 meters. Beyond 100, then a certain concept called attenuation kicks in. The loss of signal strength as distance increases. So as you pull these UTP cables, ensure that you are less than 100 meters, because beyond which it cannot, though there are some inventions, but still it is capped to that distance. So those are the factors that you should consider when choosing a media: the bandwidth, the speed, also the environment, the topography, the environment under which fiber is laid or run is not the same as the environment in which copper is run, or wireless. Wireless, this mostly is suitable for areas whereby there is a lot of interference, there is a lot of where you cannot lay fiber, and UTP is not the case, then you go for wireless. But where there is a lot of mountains, many mountains protruded with the forestry areas, you have to prefer another alternative unlike wireless, because they will be obstructed. There will be no LOS, line of sight. Network representation. Network is represented in different diagrams, and those diagrams are called what we call topology. To achieve the topology, symbols are used, and these are the symbols. When you see these symbols, these are a symbol for a desktop computer, this is a symbol for a laptop, then this is a symbol for a printer, this is a symbol for Cisco IP phone, or generally IP phone. IP phone, it means a VoIP, or it works over PoE, power over Ethernet. There is no dedicated adapter for power, but it is powered through normal UTP cable. So data with the voice is on one single channel. We've got wireless tablet, then we've got telepresence endpoint. So these are the symbols. If you have ever used Cisco Packet Tracer, you are familiar with this, and I'm going to show you some of these symbols in my coming labs. Intermediary devices, those devices that are within the heart of the network. It might be a wireless router, a switch, a multi-layer switch. This is a layer 3 switch. This is a layer 2 switch. When I speak about layer 2, layer 3, I'll come later to talk about the OSI model, Open System Interconnection. Then this is firewall. Then this is a router. So in addition to device representation on the right, this section, it is important to remember and understand the following terms. We've got network interface card. This is the chip that is printed on your motherboard that helps you to connect to the network. We've got physical port, just like a normal RJ45 port where a UTP cable is plugged in, then an interface mostly is applied on the router. The surface of a router, or the ports of a router, mostly are called interfaces. And these are the symbols for cables. When you see such kind of symbol, is a wireless media. Then this is a LAN media, possibly a UTP or a copper cable, that is. Then this is a WAN media, wide area network media, connecting from, it's a link in between the ISP and the organization. Yes, this is the engine that brings life to your internal network. Without this one, there is no all those advantages of network that we had discussed before. Topology diagram. So this is the topology. We've got two main types of topology diagram. We've got physical topology and we've got logical topology. Note the key differences between in the exam. This is always a common question. Physical topology is where you see how real physical devices are laid out. Like you can see this is the data center or the server room number 2858. Then this is the internet, this is the router and intermediate devices, this is a switch and intermediate devices connecting to IT office room. Then this is also room 2124, with a rack of having 3 switches connected to different rooms also. So you can cable this network in Cisco packet tracer and achieve this. So this kind of where you interact with the physical devices, that is a physical topology, and where now you check what the network is having now, like the IP addressing, how packets are flowing in the network. That is now a logical topology. For example, this computer from this network sends a request to this web server. The packet, as it moves, it is passing through a logical topology. So we've got types of network. This one I had already talked about it in the initial slide. So local area network, this is your just home or small area network that covers a limited geographical area. It can be within one room or a compound or a town, just a small town. Wide area network spans large geographical area, typically involving telecommunication service provider. So like in this section LAN here, it can be maybe you are connecting your phone through a Bluetooth to a computer, or you are connecting your 2 phones maybe to a computer, or you've interlinked your 2 computers. That's a LAN. You have control over it, and it is easy to set up. Wide area network now, it spans across cities or multiple cities. This is where ISP, Internet Service Provider, are involved. So they ensure that multiple cities are interlinked, and when such happens, it forms a wide area network. In summary, wide area network composed of multiple LANs. Other types of networks, we've got metropolitan area network, in a city, wireless LAN, that is a local wireless network. We've got storage area network, that is meant for storage. You can see the picture here. This is one of the computer that has been configured to serve as a server here. Then through this switch, this can access services through this to this. So you see the characteristics spans a small geographical area such as a home, a school or office or building, or a campus, as a university, usually administered by a single organization or an individual, you see. Also provides high speed of bandwidth to end and intermediate devices within the network, because the network is not overwhelmed. If you are just 2 people having the access to this server, the server can work fast for you. Next, wide area networks. You can see this network is connected to this network. I told you wide area network is a composition of multiple LANs, and that one you might have no control over it, because the interconnection between them needs a third party, that is the ISP, Internet Service Provider. Also, wide area networks typically provide slower speed because of what? There are multiple users relying on them. The internet. Now when you come to the internet, then it composed of interconnected LANs and WANs. So multiple WANs form the internet. As you can see, the ISPs are many. The service providers are many here. So you can see here, school LAN, business LAN, home LAN, hospital LAN, and a LAN. Remember, a LAN can be changed to other LAN. So the internet is not owned by an individual. That is what it should sink to you. The internet is not owned by an individual or a group. However, there are some groups that were developed just to help maintaining the structure, but there is no direct ownership of internet. We've got IETF, Internet Engineering Task Force. We've got ICANN. We've got IAB, Internet Authority Board. So those are the bodies that just helps to structure and maintain the internet. Like this Internet Engineering Task Force, this one deals with how the real structure of the internet should be. ICANN deals with the IP address, how the IP addressing is managed. So I'm done with that section, how the internet is. You can go deeper in that. So these are the small types of networks also that you can that you can understand. In a big organization, a network can be divided depending on the users or the type of the user that's gonna be used. This is a company network. This is a company network. So this is an internal network, responsible or usage within it is used within the company only. Intranet from the internal network. Then when that network is expanded to connect suppliers, customers, or collaborators, it is called extranet. So a supplier, you find that a supplier has a tunnel through which he or she can use to access the resources of a company as logistics or supply chain is related. So the network he is using to access the resources to the intranet is the extranet. It's an extended network from the intranet. Then you see all these people are enjoying the benefits of the internet. You see, the internet is the bigger circle now. The internet is the bigger circle. So all the two, they are functioning within this. If this does not work, then the two are down. So there are technologies that are used to access the internet, and these are the technologies used mostly by the service providers. There are many ways to connect users and organizations to the internet, depending even on the cost first. Popular services for home users and small offices include broadband cable, broadband digital subscriber line, that is DSL, digital subscriber line. Wireless one, we've got, like, you can be connected by the service provider through wireless wide area network, and mobile services. Organizations need faster connections to support IP phones, video conferencing, and data center storage. So these two kind of resources need to like always use what we call quality of service, whereby speed is given priority or data is given priority. Voice in a network is always given a priority, and that one most organizations always specify that such kind of data should be within the network that has got a greater bandwidth. So business class interconnections are usually provided by service providers. Business class interconnections are usually provided by service providers and may include business DCL. So here in this section here, home, you can be connected by a digital subscriber line for home, but also A business can also be connected through a digital subscriber line, but for the business package, not a home package. Also, it can be connected through leased lines or Metro Ethernet. Home and small office, that's SOHO. You can see there is a cable. It can be connected through a cable. High bandwidth, always on internet connections offered by a cable television service providers. DSL, high bandwidth, always on internet connection that runs over the telephone. We've got cellular, uses a cell phone network to connect to the internet, only available where you can get a cellular signal. So at your own time, read about this internet connection and how are used, and examine properly which kind of connection are you using. Hopefully in the 21st century, most of people are connected to the internet. They have maybe internal home Wi-Fi. Check how you are connected. Satellite, so the aspect of the current Starlink falls here, whereby irrespective of the interference, the satellite, one parent or master satellite is hooked in the sky so that it connects all people, depending whether you live in an area whereby you are obstructed by maybe overgrown trees, etc. Business internet connection. So these are ways that are used to connect businesses to the internet. So the business, the way you are connected at home, it cannot be the same way the business is connected, because a business, it might have further local area networks that need to be dedicated to their connection at the head office. So there must be a proper way of connecting them to the internet. For business, we've got almost 4 types. We've got dedicated list lines. A dedicated list line, it means there is a section here. They talked of list line. List line, they just give you a specified line for you. But when they say, and it can be shared, they can list you a line that is shared. So you are not assured of the internet speed. But for a business, they list a line to them only. That one is what is meant by the dedicated. Reserved circuits within the service provider's network that connect distant offices within private voice and or a data network. Ethernet wide area network extends LAN access technology into the WAN. So for example, another way they can use Ethernet WAN to extend your local LAN, because remember, computers in LAN cannot access the internet, not unless a third party or a subscriber service provider is involved. So from business standpoint, if we go for digital subscriber line, we used business digital subscriber line that is always available in various formats, called symmetrical digital subscriber line. Then satellite can provide a connection when a wired solution is not an option, and that is always possible when maybe the distance is beyond maybe what fiber can cover, maybe what a UTP cable can cover, and also maybe connecting maybe continents and continents. So still fiber can do, but so depending on the need or the objective, you may choose satellite. So this is a packet tracer. This is a packet tracer. Help and navigation tips. Overview of the packet tracer program. Packet tracer is a software program that helps CCNA students by allowing them to experiment the network behavior build networks, and find the answers to your what if questions. So you can see here, this is a branch. This section here, this section is a branch. Then this is central. Then this is home office. All of them are connected, but you see these red links. This is a subscriber. A subscriber has connected this, has connected to this, to the internet. So this is just for packet tracer. Now the network as a platform. What do they mean when they say network as a platform? Traditional separate networks. In 30 years ago, how were the networks? And currently in 21st century, how are the networks? You experience that in 30 years ago, the kind of networking technologies that were used, they are totally far different from what we are using currently. Because ancient times we used to have old switching techniques, but right now we've got modern switching techniques like packet switching. You can see here, these computer networks, telephone networks, broadcast networks. So things have evolved. We've got this section, converged networks. So traditional networks, data and voice were separate. They were flowing on different pathways, unlike in modern networks whereby data and voice is integrated, and that one leads to the formation or the creation of converged networks. Converged networks, data networks carry multiple services on one link, including data, voice, and video. And in such network scenario, we use a concept called quality of service, whereby voice and video is given priority over just a normal data. That's what you should understand. Unlike dedicated networks, converged networks can deliver data, voice, video between different types of devices over the same network infrastructure. So converged networks do save time in transmission compared to dedicated networks where every kind of data is separate. So the network infrastructure uses the same set of rules and standards. So there is an organization responsible for standards, that is International Standardization Organization, that is OSI, and it achieves that through the OSI model, Open System Interconnection model. I'll talk about that. So this is a small research on the converged network that survey your understanding of convergence. You can do this lab in Cisco Packet Tracer. When you go to NetLabs Hub on YouTube, there is a video that I created on combining data and voice, and you can see how I configured that. That is an example of converged network whereby data and voice is just moving in one line. This is a scenario whereby you see a Cisco IP phone is powered with one cable, then another cable is connected to that phone, and it's powering or it's connecting to the PC or a laptop. So the computer is getting an internet from the phone. That's just same link. That's a kind of converged network. So there are some network architecture. So for you to have a reliable network, it means that you depend on it. When you need it, it's available. When you need maybe to learn, to collaborate, to do what, it's available. It's faster. It gives you your needs on time. So there are some of the principles that are followed for you to ensure that you've got a reliable network. And this is a key to a keynote to network engineers, people designing networks, planning the structure of the network. These are the consideration or the factors that should be put into consideration if you are the network engineer and purporting to design and configure and have deploy or implement a reliable network. Like these kind of networks from providers that keep on maybe having some intermittence now and then. In the morning it's there, in the afternoon it's not there, in the evening it's totally not there. That's not reliable. So there are some of the principles back and they were not followed, and missing such, it's now leading to such. So network architecture refers to the technologies that support the infrastructure that moves data across the network. What are these technologies that support data? We've got fault tolerance. Fault tolerance is a scenario whereby the network is expected to take minimal downtimes when a hitch or a glitch happens within that network. For example, when power goes, or when we've got power outage, the network should take the minimal time for it to be alive again. Meaning, for you to achieve that, in that network, all networking devices should be powered on UPS, uninterruptible power supply. They should have power backup. Second thing, your electricity layout should be done with an expert with the required materials. But if you bring a quack to do wiring for you, one day you are buying a switch, another day your router is off. So that's what you will achieve, and that one will not enhance in achieving a reliable network. So fault tolerance, we expect minimal downtimes. Even if there are downtimes, let it take shortest time to come up, or it automatically restores. We've got scalability. Scalability, when a network engineer is building a network, he or she should factor in the aspect that network always grows. Network always grows. It means that if an organization has 5 people and in 2 years it has 60 people, you see? So from 5 to 60, 55 people, these are the people that have expanded your network. They will need more socket LAN connection, you see? So if you minimized your network during developing stage, it will be difficult for you to expand that. So you should build a network in a manner that it is easy to expand, starting from using a large internal IP address scheme, leaving some IP address for the future. So that is scalability. We've got security. A reliable network should be secure. These are the ways you can secure your network. You can use a firewall. You can use a load balancer to distribute traffic. You can use ACL, access control lists, to filter traffic or to deny and allow traffic depending on the need, where they are coming and where they are going. So, or you can use wireless routers. Wireless routers have some security features that can achieve such. So that is security, one of the network architecture. Then quality of service. This is the aspect I had talked about it earlier, that there is priority given to video and voice in a network. So that is it. These are 4 basic characteristics that underlying architectures need to address to meet user expectation. So fault tolerance, scalability, quality of service, security. So I have explained all of them. I I'll just move faster. A fault-tolerant network limits the impact of a failure by limiting the number of affected devices. It means that your network should have redundant pathways, in that if at all one route or one link fails, it can use the other link. So this router here, maybe it has blown by power, interfering this connection. So still, these computers can get service through this path, and that is fault tolerance. Multiple paths are required for fault tolerance. You cannot just use one link. Having a single gateway cannot save you. Scalability. Scalability. A scalable network can expand quickly and easily to support the new users and application without impacting the performance. That one can only be achieved when you've got, if you left a good IP address scheme. For example, if you had subnetted, you just need maybe 8 IP addresses, then you exactly came up with the 8 only. What if new people join that organization? It will be difficult to connect them. So that is scalability. Quality of service. Voice and live video transmission require higher expectation for those services being delivered because they are bandwidth hungry. So they are given a priority. Security. How can you achieve security in your network? Network infrastructure. You start security from the infrastructure standpoint of the network. Then physical security. You ensure that the data center is situated in a location that is far from commotion. You also preventing unauthorized access to the management softwares on those devices. Also information. So security talks about, it's more detailed. Security starts from the network infrastructure, physical security, information security, system security, and there are some of the CIA triad that is used to achieve security. Confidentiality, we've got integrity and availability. Assurance of timely and reliable access of data to authorized users. That's availability. Integrity is the assurance that the data has not been altered. You assure users that their data is not going to be manipulated by intruders or threat actors. Confidentiality. Only intended recipient can read the data. There is no impersonation on that. The changing network environment. If now the network look the way you view it, in 20 or 5 years to come, how will they be? Things are changing. Now we are moving from the network that we used to lay cables around. In most of first-class countries, they have moved away from such. Now you can build the entire network in the cloud. For example, in AWS, Amazon Web Services, you can use what we call VPC to create subnets. That is, you create departments in organization and share resources, do all those things we always do on the ground in the cloud. You can see that's where we are going. Cloud computing. Another section we are now becoming to use satellites, the so-called of Starlink and other things. Very soon another subscriber can pop up with even a powerful satellite, unlike what Elon Musk is using. New trends. What are these trends in networking? These are some of the new trends. This is one of the concepts that I had explained before during the start of this particular chapter. Bring your own devices. Right now, majority of organizations have allowed users to bring their own devices to, minimizing if the money they could have spent to buy them. So This is an example. For example, you buy your laptop, then you use that laptop to work for the office work. So that is the BYOD concept. Online collaboration. People are starting to work from home. Majority of organizations are minimizing on expenditure by not building physical structures or renting offices, but just achieving company's objective at their home's comfort. Video communication. Video is a real-time information source of giving information. So like people prefer videos unlike just audio, because video you are seeing the person, unlike the sound can be manipulated. But if you are just, even right now with the AI, there is nothing that is possible. We've got cloud computing. There is a lot of cloud partners or cloud providers, starting from Microsoft, that is Microsoft Azure, AWS, Amazon Web Services, and Huawei. They are providing cloud hosting, organization resources in the cloud, not limited to website, not limited to domain name services, DNS, not limited to email, not limited to files, not limited even to control systems like CCTV. Now CCTV are configured, surveillance cameras are configured to store their footage in the cloud, unlike using the old network and video recorders, NVR. So you see, in the cloud you can record any kind or any size of footage that you want, unlike on NVR that is limited. So those are the trends in networking. Bring your own device, online collaboration, video communications, and cloud computing. Bring your own devices is a major global trend that allows users to use their own devices, giving them an opportunity and greater flexibility. Because if you are given the laptop for the organization, you struggle to use it, unlike if you could have just carried yours to that environment. But that's a security threat, so most of the organization do prohibit that. Individuals want to collaborate and work with others over the network on joint projects. You see, on this first line here, this is where Git and GitHub comes in, whereby developers or software engineers can work on the same project. One developer from USA working on the front end, another two from Kenya or South Africa working on the back end, then another one from China waiting for deployment. So, and all of them, they are just checking on the working of the other real time, the errors being created, how the troubleshooting is done. Git and GitHub manages that all for you. Collaboration tools including Cisco WebEx. Cisco WebEx, this is a collaboration tool that has just been introduced to help learners. Now, even this course, Cisco provides through online meeting through WebEx. For example, like for Microsoft uses Teams, bringing people closer, bringing all people in a specified or in an organization into the same container, so that you can call one of your colleagues irrespective of the location if he's within that organization through Teams. And it's possible. People conduct meetings through Teams, share these particular resources through Teams and other collaboration tools, the likes of Zoom, Teams, TeamViewer, Google Meet. There are many collaboration tools outside here. Video communication, you see, these people seem to appear in one room, but they are in different locations. Cloud computing is a global trend that allows to store personal files or backup back data on servers over the internet. Generally, cloud computing is just provision of IT resources over the internet on a pay-as-you-go pricing. You just pay what you've consumed. Unlike having a 10 million data center that in 1 year you've just utilized maybe 1 million or 500,000. So where else is 9 million? Where else is 9 million? 9.5 million going? That's a waste. You better pay 500,000 for Amazon to set up the data center for you, or you set that data center in the cloud and you pay as you use. The time you are not using, there is no charges for that. You can see this is what you can do. So the cloud is divided. We've got private clouds, we've got public clouds. So we've got public cloud providers and private cloud providers. And also, you as an organization, you can customize your cloud. As a network engineer, if you are passionately in network engineering or in telecommunication, this is just my advice to go. Try to blend your networking engineering skills with the cloud computing, because very soon, with this evolution of AI tools and other things, as tech is being transitioning, you might be rendered useless. I don't necessarily mean you will be useless. You'll just be useful, but your usefulness is not needed. So that one can be termed as uselessness. So blend it with some cloud computing. You can choose AWS or go for Microsoft Azure. We've got my organization that are fully on the cloud. That is whereby if you go, cloud engineers are also cloud network engineers. If you know how to set network well in the cloud, you stand a chance in this tech revolution era. So types of cloud you can see here: public clouds, we've got private clouds, hybrid clouds. Hybrid clouds, it's just using one or two. You can use private or public, the combination of these two. Custom clouds, these are clouds that are customized to suit the needs of a certain organization, maybe a healthcare organization or a government. For example, in US, they have a dedicated cloud for the government. Technology trends in home. We've got smart home technology, the introduction of Internet of Things, whereby sensors, actuators are used to automate operations in the home. That is the current technology, having smart home. We've got what we call power line networking. Power line networking can allow devices to connect to a LAN where data network cables or wireless communication are not viable option. Using a standard power line adapter, the devices can connect to the LAN where there is an electric outlet by sending data on the network frequencies. You can see here, there is just one socket powering the entire LAN here. So that is the technology that is happening in the home networks. In the wireless networks, we've got wireless broadband. It's one of the network trends. You can see this is a mast. It is broadcasting this signal to providing services to this home. So you need to master the trends that are happening in the network. There is smart home, use of IoT devices. There is a power line networking. There is wireless broadband. Then security threats. What are also, as the network, as there are many network technologies trending, also security threats are increasing. there are threats that are happening through the network that are up for massive destruction of the organizations, whereby we've got DDoS, distributed denial of service, whereby a threat actor compromises the old systems in an organization through the network, then manages to bring the entire organization down. So network security is an integral part of the networking, regardless of the size of the network, even at home or in business or in whichever. You can just be attacked. For example, if you happen to be the target to an intruder, the network security that is implemented must take into account the environment while securing the data, but still allowing for quality of service that is expected of the network. So this one means that even though you struggle to secure your network, do not secure it into a manner whereby there is no reliable access to the data within the organization. Security is not complicated. That's when you can say maybe your network is secure. Security is just ensuring that proper guidelines are given or followed, but it should not limit or block or deny the services that should be needed by the people. Securing a network involves many protocols, technologies, devices, tools, and techniques. So protocols, we've got like simple network management protocol, we've got DHCP for assigning IP address automatically, we've got DNS managing domain names, we've got SMTP for managing mails. We've got a lot. So you can read about this is coming in the advanced chapters. Security threats, there are external threats and internal threats. So most of the security engineers or cyber security people or experts do focus on external threats, but there is the most dangerous is an internal threat, whereby a user within the organization is less assured to be faithful to the organization information or data, but that person, if at all he turns out to be a threat actor, can bring more losses than benefits compared to external threats. So these are viruses, worms and Trojan, spyware and adware, zero-day attacks, also called zero-hour attacks. We've got hacker attacks, denial of service, data interception, identity theft. Identity theft is where a person claims to be another person. At the end, he performs a crime and goes scot-free that way. So these are threats that you should master. Viruses, worms, and Trojan horses, these are the threat actors use them to purport as if they are a real thing in disguise, but it's not. For example, an intruder can use a flower. For you, you are seeing a flower. In real sense, that's not a flower. It might be a virus or something else. So that's such kind of attacks is Trojan horses. They perceive to be real, but not what you see they are. Security solutions must be implemented in multiple layers using more than one security. Network security components for home or small office, they are different. For example, for home you can use antivirus and spyware. For organizational corporates you can use firewall, and right now even in the arena of firewalls there is a great advancement whereby in modern networks they are using combination of one or two, either FortiGate or Palo Alto or Cisco Adaptive Security Appliance or Sophos. So there is a lot of them, those UTM, Unified Threat Management. Larger networks have additional security requirements like dedicated firewall systems, access control list, intrusion prevention system, intrusion detection systems. We've got virtual private networks, that's the VPN. We've got DMZ, demilitarized zones, whereby dedicated data center is secured far away from the organization. Cisco network architecture. In order for networks to function while efficiently supporting connection of people, devices, information in media-rich conversion environment, the network must be built upon a standard network architecture. The network architecture refers to the devices, connections, and products that are integrated to support the necessary technologies. As you can see, these three people here, this is a data center. It's made of many rackers here, and these rackers have multiple devices, switches, firewalls, routers that are anchored to achieve one common objective: provide connections to the people. So we've got this organization, we've got these certifications, and this is how Cisco has arranged its certification. At the entry level, we've got the associate level, we've got professional level, expert level, and then architect level. So entry level, these are just basic courses like introduction to networks, but not this one. So once you finish this course, this CCNA 1, CCNA 2, CCNA 3, it is modularized in 3 packages. Then you do the relay exams from Cisco or through their partners. Then you stand a chance to be Cisco Associate. That is Cisco Certified Network Associate. So for entry level, there is an exam called Cisco Certified Entry. So that is for this section. So when these are part of the journeys. You see, first exam is this one, then second exam is this one. So I'm preparing you for this one. Though Cisco has developed or revolutionized in how its certification is done. So you find that this part and this part, they are just bundled together. Researching IT and network job opportunities. On Cisco website, currently there is an option for careers, whereby when you master Cisco, you can stand a chance to gain some opportunities. So this is the summary. Let me summarize on what we've learned today, that are warriors of the net. We've got this. There is a video here. When you go to the warriors of the net, there is that. Conclusion: exploring the networks and internet have dramatic impact. So this chapter has talked about the impacts of network to our lives, improving business production, has expanded education, how education is given or learning in general. It has even increased security, collaboration, reduced costs. Those are the impacts or the benefits of the network. And the network consists of two devices or can be as large as the internet. So that one talks about the network types. We've got a LAN, we've got WAN, we've got personal area network, whereby you connect a Bluetooth to a computer. That's your small network. There is network infrastructure, which is the platform that supports the network, and the infrastructure is composed of multiple technologies, devices. An infrastructure contains of a data center, and within a data center there is a lot. There is power, there is a network switches, routers, firewall, load balancers. That is the engine, where the source of information on a network. So a network must be fault tolerant. It should stand the downtimes or the failures. You can achieve fault tolerance through use of multiple pathways in a network, that is redundancy. Scalable, your network should have the ability to grow. Ensure that if your IP addressing scheme is large enough to cater for the future. Support for quality of services, video and voice in majority of the organization is given priority. So such, if at all a department you hear as a network engineer that will support video and voice, ensure that it is given priority in terms of large bandwidth, unlike data in other section. The network should be secure. Use firewall. Ensure that configuration are well done. Security patches are done on the devices. Implement physical security, information security, data security, all those to achieve that. Thank you so much for this course. As we wind up, I would like you to appreciate you for having taken your time to learn CCNA 1, Exploring the Network. Thank you. Let's meet in the next class.